All right, so we see here the metric number line with the base unit here on this side of the number line. We're going to go ahead and pencil in. This will be 10 to the third, so this is bigger. This is 1,000. This is a kilo with the abbreviation of K. Next to this next decimal point over would be 10 squared, 10 to the first, 10 to the 0. The base unit doesn't have any decimal point moving, so this is just the base unit. We'll call it 1. And then as we go from these bigger units to smaller units, right, we're going to see that this is 10 to the minus 1, 10 to the minus 2, 10 to the minus 3, keep going all the way, 10 to the minus 5, 10 to the minus 6, 7, 8, and 10 to the minus 9, 10 to the minus 12. We're going to skip over those because they just don't really show up in any meaningful way. The important prefixes to know is that 1/10 is a decimeter or deci, depending on what base unit. Deci has the prefix of D. 10 to the minus 2 is centi with an abbreviation of C. 10 to the minus 3 is not kilo, it is milli with abbreviation of M. Skipping over to 10 to the minus 6, this is a micro with a funny little U symbol. 10 to the minus 9 is nano. This has a little n, and 10 to the minus 12 is a pico. Okay, so this is a metric number line just to give you an idea of how many decimal places you are away from the next unit. This will be helpful as we work through our conversions. Understanding relative sizes of units, using this metric number line to decide which of the following units is bigger. 1 centimeter versus 1 picometer. So find those, right? So a centimeter would be here, a picometer would be here. Centimeter is definitely bigger. So we're going to put a sign here indicating that 1 centimeter is bigger than a picometer, right? So we're just trying to understand the size of one compared to the size of one of these others. Who's a bigger unit, right? So microliter versus a milliliter. So here's the milliliter, here's the microliter. The milliliter is going to be the bigger unit if we're comparing one of each. 1 nanogram versus 1 microgram, right? One of each, we would see that the microgram is a bigger unit. 1 second, that's the base unit because there's no prefix, versus a millisecond, right? We would say that 1 second versus 1 millisecond, the 1 second is a greater quantity than 1 millisecond. Okay, so understanding that can be very helpful. And let's then take that and create what are called equality statements, comparing two prefixes. So creating equality statements begins with understanding which of the two units is the larger unit. It's easiest to create an equality where you have one of the larger unit, which means you will have many of the smaller units. Now, before we do that, let's make sure we have our abbreviations down, okay? So if you're talking about kilometers, right, or kilometers, that would be an abbreviation of km, versus meters, which is just m, no prefix. Milligrams is a little m and a little g, milligrams, mg, versus grams with no prefix of g. Microliters, that's that funny little u, followed by, I generally use a capital L because otherwise a lowercase l looks like a number 1, versus liters, which is just the L. Picometers will be PM, meters just M, kilograms, kg, and grams, g. Okay, so now that we have our prefixes sorted out, we are meant to compare the size of a kilometer, kilometer versus a meter, right? So kilometer is a kilo versus a meter, which is the base unit. The kilometer is definitely the bigger, right? So we're going to say 1 next to the kilometer. We're going to put a 1 next to the larger unit. And then we have to decide, okay, well, how many meters is in that, right? Well, 1 kilometer, kilo, is 10 to the third. And a meter is 10 to the 0, or 1, right? So that's just a difference of 1,000. So we're just going to say you could say 10 to the third, or you could say 1,000. Either way, it's the same value. Comparing 1 milligram to 1 gram, let's go up and take a look at our number line. 1 gram is our base unit. and milligram is 10 to the minus third. So we're talking about the base unit having a value of 1 and milliliters 10 to the minus third. So I'm going to put that right here, 10 to the minus third. Grams is just 1, right? And so we see here that of these two units, the gram is the larger one. So we're going to say 1 gram. Now, if we look at these two exponents, milligram is 10 to the minus third, a gram being the base unit is 10 to the 0. We say that that's a difference of 10 to the third power, right? That's a difference of, like, this is 1/1000th, and this is just 1. So we would say that 1 gram is larger by 1,000 times, or 10 to the third times. Right, depending on how you like to write it. 10 to the third is the same thing as 1,000. Microliter versus a liter, right? The liter is the base unit. The microliter is smaller. So we're going to say that in 1 liter, how many microliters are we going to have? Well, the microliter is 10 to the minus 6, right? That's a millionth. So we would say that there's not 1/1,000,000th microliter in 1 liter because it's smaller. We would say it is a million. There's a million of these microliters in 1 liter. That's the same thing as saying 10 to the 6th, of course. Meters versus picometers. A meter is much bigger than a picometer. So 1 meter is equal to pico. Pico is 10 to the minus 12. So we would say that there are 10 to the 12th picometers in 1 meter. This is a trillion. So that's a lot of zeros. Something like that. And this is where you can see that putting things into exponential form is a little bit simpler to write. Kilograms versus grams. The kilogram is a larger unit, so we're going to say 1 kilogram. And of course, kilo means 1,000, so that means we have 1,000 grams in 1 kilogram. Now, a note about these problems. Did you notice that when we were comparing these, only one value had a prefix? But in our next set of notes, we're going to take a look at comparing these two, where both of these, right, both values have prefixes. And this is where the number line is going to be helpful. So use the number line. And so let me get that number line handy, right? Okay, so here's what we have. We have to decide what's bigger, the micrometer, which is UM, versus centimeters CM, right? So here's a micrometer, here's our centimeter. The centimeter is listed as 10 to the minus 2. The micrometer is 10 to the minus 6. Which one is bigger? Well, the centimeter is bigger, so I'm going to say in 1 centimeter, how many micrometers there are. And to answer that question, we're going to compare these two exponents. We can see that they are off, right? They are 4 decimal places away. So we would say that there's this 10 to the 4th micrometers, which is the same thing as saying 10,000. So 1 centimeter contains 10,000 micrometers. And again, we figured that out because those are 4 steps away, 4 decimal places away. And so that's 10 to the 4th, which is the same thing as 10,000. Okay, let's take a look at the next one. Nanograms versus kilograms. Oh, there's a little typo there. Nanograms is NG, kilograms is KG. So what's bigger, a kilogram, which is 10 to the 3rd, or nanograms, which is 10 to the minus 9th, right? So the kilograms is much bigger. So we're going to say in 1 kilogram, how many nanograms are there? Well, on the number line, going from 10 to the minus 9th to 10 to the 3rd, that's a total of 12 decimal places. So we would say 10 to the 12th nanograms, right? And I'm not going to write that out, but 10 to the 12th is a trillion. So a trillion nanograms are in 1 kilogram. All right, milliseconds versus microseconds. Milliseconds is MS, microseconds is US. Which one is bigger? Comparing milli and micro, milli is bigger, so I will say 1 millisecond is how many microseconds? Well, milli is 10 to the minus 3rd, micro is 10 to the minus 6. That's a difference of 3 decimal places. 3 decimal places is 10 to the third, or 1,000. So we would say that there are 1,000 microseconds in 1 millisecond. Kilograms versus milligrams, kg versus mg. Milli is 10 to the minus third, kilograms is 10 to the positive third. That's a total of 1, 2, 3, 4, 5, 6, right? So kilograms is bigger, 1 kilograms is 10 to the 6th milligrams, which is the same thing as 1 million. So there's 1 million micrograms in 1 kilogram. And our last equality that we're going to work out here today is milliseconds versus nanoseconds. Milliseconds is 10 to the minus third, nanoseconds is 10 to the minus ninth. That's ms and ns. Milliseconds is bigger, so we're going to say in 1 millisecond, there are 10 to the 6th nanoseconds. Again, that is 1 million. Oops. Okay. So these are what we call equality statements, right? These are equality statements, which are going to be very useful as we create what are called conversion fractions. Conversion fractions are fractions that are equal to 1, meaning that the numerator is equal to the denominator. Right? 2 over 2 is equal to 1. Apples over apples is equal to 1. So anything over itself is equal to 1. Right? So the idea here is that if we go take a look back at the fraction in number 1, that was on the previous page right here. 1 kilometer and 1,000 meters. They're equal to each other. So if you said 1 kilometer over 1 meter, that's equal to 1. Switching it or flipping it, 1 meter over 1 kilometer is also equal to 1. Okay? So flipping these fractions, because the numerator, no, and that's so wrong. Let's start that over again. That's, of course, 1,000 meters. My apologies. Right? 1 kilometer over 1,000 meters is equal to 1 because these two are equal values. These two are equal values, right? So the idea is that anything over itself doesn't matter which is on top, which is on bottom. If we take a look at number 2 from the previous page, we're looking at 1,000 milligrams and 1 gram, right? So we could say 1 gram over 1,000 milligrams, or 1,000 milligrams over 1 gram. The idea is that both of these are equal to 1. If we look at number 6, we could say that 10,000 micrometers is equal to 1 centimeter. We could say that 1 centimeter is equal to 10,000 micrometers. Either way we write this fraction is equivalent to the value of 1, because anything over itself is equal to 1. And of course, we could do one more example here, but I think you're getting the point. 10 to the 12th nanograms, and this is just coming from number 7 up higher up on the page, is equal to 1 kilogram, or we could say 1 kilogram over 10 to the 12th nanograms. Okay, so getting familiar, getting comfortable with this idea that a conversion fraction is a fraction where the numerator is equal to the denominator based on equality statements are going to be very useful as we start to use them in a technique known as dimensional analysis. So what is this and when do we use it? So when you are given a quantity in a specific unit, but you need to express that quantity in a different unit, you will use dimensional analysis, which involves multiplying the original quantity by a conversion fraction so that the original unit cancels out, leaving you with the desired unit. And the end goal of dimensional analysis is it sets up a way for you to communicate how you got to the converted answer. Okay, so the basic idea, the basic structure is you're going to start with the given value. You're going to multiply by some conversion fraction. That conversion fraction is going to be some kind of equality that, like we just worked on. And then that's going to be equal to your target value with the target unit. Okay, so that's the basic structure. So if we look at this first example, a Nordic ski race in Wisconsin is 55 kilometers long. How many meters is this distance? Now, you may have like an intuitive sense on how to do this calculation, but how do you convince someone that that's the right calculation to do? So the idea here is you start with the given quantity, you start with the given unit, so 55 kilometers. We're then going to multiply by a conversion fraction that will convert between kilometers and meters. And to do that, right, this conversion fraction has to be set up in a way that the original unit of kilometers cancels out. And the only way we can do that is to put kilometers into the denominator. We would then put meters up top, okay? And so the idea here is what's equal to what. So the idea here is to figure out which one of these two units is bigger, okay? 1 meter or 1 kilometer. Well, 1 kilometer is bigger, so we're going to put the 1 there. And then, of course, you're going to say, well, how many meters are in 1 kilometer? And you're going to know that that's 1,000 meters, or you're going to figure it out using reference tables, right? And so this right here tells you that you're going to multiply by anything that's in the numerator, and you'll divide by anything that's in the denominator. So this becomes 55 times 1,000, right, which of course is 55,000. Not tricky math there. But the idea here is that kilometers over kilometers is going to cancel, and meters does not cancel, right? So this is how we can substantiate this whole business right here. This whole thing is important to show your work on how you get this answer. Let's try a couple more. The dosage for a particular medication is 250 milligrams. What is the dosage in grams? So we're going to start with our given value of 250 milligrams, and I'm going to set myself up a conversion fraction where I'm going to put milligrams in the denominator so that it'll cancel out, and the target unit of grams is going to go up top. I'm going to know that 1 gram is bigger than 1 milligram, so I'll start by saying 1 gram. And I'm going to figure out that how many milligrams are in 1 gram. And since milligram is 1/1000th, that means that there is 1,000 milligrams in 1 gram. And when we multiply everything across the top and divide by anything that's in the denominator, we're going to see that milligrams over milligrams cancels, and our final answer works out to 0.250 grams. A cell measures 75 micrometers in diameter. What is the diameter in centimeters, right? So we're going to start with 75 micrometers. We're going to multiply by a fraction where micrometers is in the denominator and centimeters is in the numerator. I'm going to take a look at my number line here, right? Because here we have, this is a metric conversion where both of these values have a prefix, and I'm going to see that centi is here and micro is here, so the centimeter is bigger. So if I have one of those, how many micrometers will be in that? Well, 10 to the minus 2 versus 10 to the minus 6, that's 10 to the 4th. 10 to the 4th is the same thing as 10,000, so whichever way you're happier putting that into your calculator is fine, right? And so micrometers over micrometers will cancel, and this becomes 75 divided by 10,000, and we're going to see that that is 0.0075. I believe that's right. Let me do that one more time. 75 divided by 10. Yep, 0.0075. And of course, it's very important to make sure you have that unit on your final answer, because that is the whole point of the calculation. Last question on this page, the blink of an eye takes 350,000 microseconds. How long is this blink in milliseconds? So we're going to start with 350,000 microseconds. We're going to set up a conversion fraction where microseconds is in the denominator and milliseconds is in the numerator. Milliseconds versus microseconds. Milliseconds is bigger, so 1 millisecond. And then how many microseconds are in that? Well, the difference here is 10 to the 3rd or 1,000, right? So when we multiply everything across the top, divide by anything on the bottom, microseconds over microseconds will cancel. and the math becomes 350,000 divided by 1,000, which really I should not have needed a calculator for, but here we are. Okay, so that right there is how you use dimensional analysis to help you convert between metric units. What we're going to see as we move forward is this is a technique that can be used to help you solve lots of problems, not just metric conversions. And this is where we're going to pick this up in a third video to parse this out a little bit.